All right, write this down, please. Linear equations. There are, well, let's just do this. Why do you suppose they're called linear equations? Because they're equations that give you lines. Remember we talked about parabolas? That would not be a linear equation. That would be a quadratic, whatever it is. I don't know. Anyways, right now you're going to have two. There's three different ones we'll probably get into. But two we know. We have a linear equation that is slope-intercept form. You will remember this from last year, I hope. That was where the equation looked like this: y equals 1/3 x plus 2. It's called slope-intercept because you're given two things. Guess what they are? It's called slope-intercept because you're given two things. Guess what they are? The slope and the... Let's see, you just got to talk louder to people. That means this. You'll remember this. By the way, it's actually probably should be called slope Y-intercept. Because if you were given this equation, the first thing you're supposed to do is look at the last number. And the last number is called the Y-intercept, which is where it crosses the y-axis. Crosses the y-axis at +2. Stop me if you don't remember this. You must remember this. We did this last year. Didn't we, Joseph? Do you remember this, Joseph? And then the number in front of the x is the slope. And if you remember the slope, the top number is how much it goes up or down. Bottom number is the over number. So from here, it goes up 1 over 3. Now the problem is, how do I know if it goes over 3 to the right or over 3 to the left?
Rise over run.
It is rise over run, but still, how do I know how do I know if I connect this point to this point or this point to that point? This is a positive slope, and positive slope goes uphill from left to right. Negative slope goes downhill from left to right this way. So I have to pick this dot because that makes my line go up like this. So there is your short yet sweet reminder of the equation. That has nothing to do with what we're doing today, just so you know. Today, we talk about the second type of linear equation, and that are the equations that are in standard form. I don't think we did standard form, did we?
Yeah.
Oh, great. So this is all review. Standard form, oh, by the way, the generic form of slope-intercept form is y equals mx plus b. That is slope-intercept form. Standard form, the little generic thing, is ax plus by equals c. Notice the difference. Standard form, both the x and the y are on the left side of the equation. Slope-intercept form, it's solved for y. Got that? So this is a typical standard form equation. X plus y equals 3. There's a 1 in front of that, 1 in front of that, but we don't care right now. Now, with standard form, this is what today is all about. You solve these by x-intercepts and the y-intercept. Which means simply this, ladies and gentlemen, and kids of all ages. If you can find out where the line crosses the x-axis, and if you can find out where the line crosses the y-axis, you have found the line because you just connect those 2 points. To which Connor Morgan is going to say, how do I do that?
How do I do that?
Well, here's how it is. You just do this. Cover up the y term and solve. Now, I gave you a really easy one. because we always start out easy. If I cover up the y, Zachary Roth, and this goes away, what do you see there? X equals 3. So guess where it crosses the x-axis? 3. Did we do this? We didn't.
Well, sure.
Oh, I'm sorry if I'm baiting it for you then. So
Right.
x,
No, please keep going like this.
the x-intercept is 3 because if I cover this up, it crosses, I solve it and I get x equals 3. Well, the y-intercept is the same thing except you cover up the x term and solve. If I cover up the x term and this goes away, I'm now left with y equals 3. This is an easy one, mind you. 1, 2, 3. And there are your 2 dots. You connect your line, and that is the equation of x plus y equals 3. Standard form's a pretty simple one to solve for is y. Well, that's y. Well, it should be. I can tell you're ready for some serious. So, let's do this one. Something a little harder. 2x minus 3y equals 6. First of all, I'll ask you, what form is this in?
Standard form.
Everybody together.
Standard form.
How do we solve standard form? No, just say x, y intercepts.
Y-Intercept.
Oh, look at how good you guys are. So here, let's do such a thing. And you'll do this on real grid paper with real lines and all that sort of stuff. Let's go with green. So if I'm looking for my x-intercept, I would cover this up. I'm going to blotch it out. I'll just erase that. If I have 2x equals 6, what does x equal? You had that equation, 2 times what number is 6? 3. So the x-intercept is 3. So here at 1, 2, 3, you put a dot. If I cover up the x and I solve for y, here's where you have to be careful because there's some negatives there. Andrew, if I have negative 3y equals 6, negative 3 times what number gives me 6? Or if I divide 6 by negative 3, I get? Very good. Who would have thought? Y-intercept is negative 2. So here where x is, or y is negative 2, and then you just connect those dots. Not so bad, is it?
No.
Now let's get really snarky. What if you had this? Negative 3x plus 5y equals, I don't know, let's go 6 again. Now, first of all, I must tell you, children, graphing is archaic. And it's never a super exact science because we're not super exact and everything we use is not super precise. So sometimes close is just good enough. So this is in what form?
Standard.
This is in what form?
Standard form.
I didn't hear anybody from this side of the room. This is in
Standard form.
boys, this is in
Standard form.
girls, this is in.
Standard form.
How do I solve standard form, girls?
Y-Intercept.
Boys, how do I solve standard form?
Y-Intercept.
Alright, so you're looking at this. Cover up the y. X is going to be what?
2.
Negative 2. Now here's where people sometimes start to cry. If you cover up the x, oh no, I now have 5y equals 6. Y equals, this is where I said close gets good enough, divide by 5, y equals 6/5, which is 1 1/5. So you just get close enough. X is negative 2, y is 1 1/5. So here's 1, here's 2, 1 1/5 is just a little bit above that. You can just put it there and call it close as being good enough. So there is your negative 3x plus 5y equals 6. Everybody? And then we probably have to go over this one more time because everybody forgets this. What about these two? Oh, I'm sorry. I do. How about this? I don't know if this will work or not. What if you get this though? What form is this in?
Standard form.
What form is this?
Standard form.
How do I solve it?
X, Y, and Z.
Okay. What is my x-intercept? Well, if I cover up this, 2 times what number is 0?
0.
What is my y-intercept? This is the only time this really doesn't work. If it so happens to cross at the origin, ladies and gentlemen, that only gives you 1 point. Which you cannot draw a line through one. I mean, you can draw any line through 1 point. So how do you know what the line is? It is not infinite, actually. But that's a good thought, Zach, because that would have been something I would have guessed. I mean, I really would have. Ladies and gentlemen, if that is the case, then unfortunately you're really left with nothing else other than kind of making a table and finding 1 more point. If you have 2x plus 3y equals 0, I'll just do 1. Let's say x, y, and I'm going to pick one that works because, well, I'm just going to, if I put 3 in for x, if I put 3 in for x, 2 times 3 is 6, right? If I have 6 plus 3y equals 0, you still haven't solved this for y. How do I solve this for y? I'm going to have to subtract 6 to get it to the other side. If I have negative, or 3y equals negative 6, what does y equal? Negative 2. Then I have my second point that I can use. Positive 3, negative 2. And there would be your other line. Can we do that again slowly?
Yes.
Alright. I only have 1 point, so unfortunately I have this equation. I have to find 1 more point, and the only way to find 1 more point is to plug a number into the equation and solve for that. So I just willy/nilly picked 3. Did I pick 3? Sure. If I put 3 in for x, 2 times 3 is 6. 6 plus 3y equals 0. If I am given this equation to solve, I have to move my number to the other side, which means I'd have to subtract it over. I now have 3y equals negative 6, and if I divide by 3, I divide by 3, y must equal a negative 2. And that is the point that I used right there. And then I had 2 points, so I can go on. Every once in a while, you'll get just zeros for both of those, and then you'll be like, what do I do? That's what you do. Back to my original thing. 2 things we have to remember what they are. If x equals 3 and y equals negative 2, well, let's just do one. If this is my linear equation, what does that look like if I graph it? X equals and y equals. There were 2 different types of graph. Well, just think about this. Here's how I remember it, because I don't ever remember. I think of my table. What is x? You have no other option but 3 for x. Y can be anything. 0, negative 1, 2, negative 2, blah, blah, blah. No matter what y is, x is always 1, 2, 3. So this would be all of those points. If it's x equals 3, it is a vertical line at whatever that number is. Because no matter what y is, x is always going to be 3. Conversely and concavely, if y equals negative 2, using that same logic, you have no choice with y. It has to be negative 2. So no matter what x is, x could be 0, 2, negative 6. Y is always going to be negative 2. You get this. If it's a y equals, it is a horizontal line. Sorry. If there's no x term, you're going to get a horizontal line. If there's no y term, it's going to be a vertical line. This is emotionally draining. Does that make sense?
Yes.
Nope. What should we do? Look at page 220, would you please with me? We will just graze upon this. Most of you this will confuse the daylights out of, but hey, why not? Joseph, are you with me? Page 220. And since most of you are athletes, look at letter E. I just went to the one that said athletics on it. If Herva jogs 6 miles an hour and bikes 12 miles per hour, the equation 6x plus 12y equals 24. Let's just break that apart so you understand what they're telling you. If by some chance you are actually going to use math in your real life, she jogs at 6 miles per hour and bikes at 12 miles per hour. Okay? So let's pick jogging, the number of hours she jogs as x, hours she bikes as y. If you take 6x plus 12y, let's say she jogged for 3 hours, you'd get 18, and she biked for 2 hours, you'd get 24, so you would go a total of whatever that is. Well, she actually goes a total of what? 24 miles, right? Doesn't it say that part of the problem? She's going to go 24 miles. Okay, so this equation represents her jogging and her biking. Okay? If I were graphing this, let us graph this. Take a look-see. What form is this in?
Standard form.
We're losing so much momentum. What form is this in?
Standard form.
How do I solve it?
X, Y, intercept.
Now notice what the x-intercept is. What is the x-axis? X-axis is the number of hours jogging. Hours jogging. What is the y-axis? Hours biking. Now let's look at this. If I put 0 in for x, if I cross this up, what is y? Intercept. 2. If I put, wait a second, ladies and gentlemen, I'm gonna make this a little bit higher. Let's make this 1 and this 2. I'm gonna make these big so you can kind of see that. All right, if I cover up the x, wait, I already did it. If I cover up the y, x equals 4. 1, 2, 3, 4. Okay, first of all, you can't jog negative hours, so there'll be nothing on this side of the line. And you can't bike negative hours, so there's nothing down here. So we have to stay where everything's positive. This line represents all the different combinations of running and biking she could do to get 24 miles. All right? If she ran for 1 hour, you get something that's right about here as to how fast she'd have to jog. I don't know if it is there. If she did, let's see if this is, if she ran for 2 hours, look at it, kind of falls right here. If she ran for 2 hours, she would bike for 1 hour, which means 2 times this is 12. 1 times that is 12. 12 plus 12 is 24. If she, whatever, if she jogged for 3 hours, you get something halfway in the middle there, whatever it is. This is what you need to understand, Emily Anderson. I know I lost you a long time ago. The book is going to ask you this. What do the intercepts stand for? what is this point right here? How long has she jogged?
4 hours.
How much time has she spent riding a bike?
2.
No. What point is this?
4.
4, 0. This is time jogging, this is time biking. What does this stand for? You did all jogging and no biking, because 4 times 6 is 24. What does the Y-intercept stand for?
2.
All biking and no jogging. What happens when you don't? You see that? Isn't that fun and exciting? That's what the book was trying to get you to see with that. Your intercepts are where you have 0 of one quantity and everything else is there. I know you want to see that again, so let's look for an exact. Let's look for another case where that happens. Anybody watching outside, friend? Wait, I'm gonna find another one. What lesson is this? 30 what?
35.
Thank you, Chase. It's always good to have participation. You see another 35 there? No, I don't want that one.
17.
I want to find them.
14.
No, none of these. No, I'm going to find them. Just, you hold your breath until I find this. Take a look at page 228. We skip a lesson just for fun. Look at problem number 12 on page 228. A small child, that would be you people, decided to sell his artwork. He sold black and white drawings for $2 and colored drawings for $3. The equation 2x plus 3y equals 24 shows that he made $24. So $2, what, for color? No, $2 for black and white? Black and white?
Yeah.
No, wait, $2.
For VW, and $3 for color?
Yes.
And then they said the equation, what is it?
2x plus
2x
3y
plus 3y.
Yeah. 2x plus 3y, he made $24. So there's $2. X is the number of black and whites, and y is the number of color. And they're saying, what would the x and y intercept stand for? The x-intercept, which would be what? What would be the x-intercept in this? 2 times what is 24? What does that mean? He sold 0 colored pictures and 12 black and whites. And it is the y-intercept,
8.
which means he sold.
8 colored and 0 black and white.
Thank you, Chase. That's 2. Nobody got that. All right, let's do some math. Chase, you've been like a good student today. What should we do? I know. It's so much better when you're quiet. You should do odds or evens. What would you say would be better? Doesn't matter. If there's 30, would it be better to do odds since 30 is an even number? I think these are getting easier, by the way. Oh no, we're not doing 18. We will do odds. Odds on 35.